All right, so to start this question, at first, at what time does the object reverse direction? So the important thing to know is that the object reverses direction when the velocity, which is x prime of t, changes sign. Now this can only happen when x prime of t equals 0, but the moral of this problem is it does not have to change sign when x prime of t equals 0. So we start with x prime of t equals 0, but x prime of t equals 0 gives us candidate points where the object could change direction, and then we have to look at whether the object actually did or not. So, it all starts with x prime of t equals 0. That's our starting point. So we need to find x prime of t. X prime of t equals, so let's see, 4 times 3/4 is 3, so I have 3t cubed plus 3 times 8 is 24, so 24t squared minus 48t. All right, that's my x prime of t. And I have to set that equal to 0. So it's a good thing we spent a lot of time in Algebra 2 learning how to solve polynomial equations. All right, so the first thing I'm going to do is factor out the 3t. So I get 3t times t squared plus 8t minus 16 equals 0. And then I should recognize this is a perfect square. I mean, you could start if you want t minus 4 equals 0 if you want to start with that factoring. But what is crucial is that this means that 3 times t minus 4 squared is equal to 0. All right, so this factor is an odd multiplicity. So when that factor equals 0, x prime of t changes sign. All right, but this is an even multiplicity. So at that point, x prime of t does not change sign. All right? So the solutions to our equation, we're going to say, are t equals 0 and t equals 4. But x prime of t only changes sign at t equals 0, not t equals 4. Because the multiplicity of t equals 0 is odd, but the multiplicity of t equals 4 is even. Therefore, the object changes direction at t equals 0 and not t equals 4. All right? So even though the velocity was 0 twice at t equals 0 and t equals 4, okay, but the direction change only occurs at t equals 0 because only t equals 0 has an odd multiplicity, t equals 4 has an even multiplicity. One way you could think of this is, think of the graph of x prime of t. So we have t, all you need for the graph of a polynomial is the x-intercepts and the multiplicities. So 0 and here's 4. This is an odd degree with a positive leading coefficient. So the graph looks like this. All right, that's x prime of t. This is the velocity. So the object is going to the left until it hits 0, and then it starts going to the right, faster and faster, slower and slower, stops, then faster and faster, faster again. So basically what this object does is it starts out moving to the left, and then it changes and moves to the right, and then at t equals 4 it stops, and then keeps going on to the right again, right? So this is what happens at t equals 0. This is what happens at t equals 4. All right. Do I have anything else to say about that? Oh, then there's the second part about the second question. At t equals 4, in what direction is the object moving? So at t equals 4, x prime of 4 equals, all right, so what do we say x prime of t was? It's 3t cubed. So 3 times 4 cubed plus 24 times 4 squared minus 48 times 4. All right, we need to know So we don't need to know what this equals, by the way. We just need to know if it's positive or negative. So you can do some kind of tricky things like go, 3 times 64 plus 24 times 16 is definitely going to be larger than 48 times 4. So I already know this is positive. Therefore, the object is moving. And since it's an x of t, it's moving left or right. It is moving to the right. All right. So what you need to do to justify this, right, x prime of 4 is positive. You don't need to even write all this out. As long as you say x prime of 4 is positive, therefore the object's moving to the right, you're good. Notice I didn't even find out what x prime of 4 is. Just by analyzing this, I know that it's positive. That's all you need to know in order to answer that question. All right, so attached to this video set is a paper called Basic Motion Practice. This is basic, okay, because we're going to do a lot more with moving later when we get the integral. So that's part of your homework. We're also going to do in your book on chapter 3, page 136, number 13 and 15. These are some multi-part questions, so be prepared for that. And then we're also going to do page 124, number 33 through 36 all, and number 56. All right, and I have a quick note, by the way, on number 36. So on page 124, number 36, because a lot of people are going to be confused because it says y equals x plus 1 over x, and it asks you to find the derivative of that. Well, how am I going to find the derivative of that? You need to do some clever algebra. We'll break y up to be x over x plus 1 over x, which equals 1 plus x to the negative 1. That's what y is. Therefore, for example, y prime equals, the 1 goes away, use your power rule, negative x to the negative 2. What's y double prime? 2x to the negative 3. Okay, you have to find the first 4 derivatives in this problem, so you got to find the rest of them. All right, there you go. That's your hint on starting the homework. That is everything for today. Have a good day.